Okay, so let's continue from where we started off last week. We are on question 24. It says here, a seismic station that is 4,000 kilometers from the epicenter of an earthquake records the arrival time of the first P wave at 10:00:00. At what time did the first S wave arrive? So, real simple. All you got to do is go to Earth Science Reference Table, page 11, and we're looking for our 4,000 kilometer mark. So, notice here that it says epicenter distance times 10 to the third. What that really means is scientific notation. So, for example, this 4 is actually 4.0 times 10 to the third, meaning we're going to move the decimal to the right 1, 2, 3 times, giving us a total of 4,000 kilometers. We're going to take this up. We're going to bump the P line. The P line is at 000700. Remember, it's always going to be hour, minute, second. 000700. And that, once again, is for the P wave. But they're asking us for the S wave. So if we do that again, but we carry up and we hit the S wave, the time is 12:40, or 001240. That's for the S wave. Now, we know that the P wave, it was hit 7 minutes after the earthquake, and that time was at exactly 10 a.m. So if I know it happened at, or it was felt at 10 a.m., and I'm trying to figure out when it hit the S wave, all I got to do is really get the difference between these two numbers. So it's always going to be S take away P. In fact, let me grab a scrap piece of paper. S take away P, so our S would be 001240. Take away the P, which is 000700. 40 take away 0 is 40. 12 take away 7 would be 05. 00 take away 00 is 00. So really, we're talking about a 5 minute and 40 second difference. Now, if we know that the P wave was felt at 10 a.m., all I got to do is get 10:00:00 and add 00:05:40. That'll give me 40:05:10. Our answer would be 10:05:40. So maybe not the simplest one, maybe not the most straightforward one, but you have to be able to determine whether or not, like what you're looking for. 25, what is the approximate latitude and longitude of the Bouvet hotspot? ESRT, page 5. Let's find Bouvet. So we got a few. I've got Hawaii, Galapagos, St. Helena, Iceland, Yellowstone, Tasman. There's Bouvet. Now, we've got to figure out whether or not Bouvet hotspot is on the western hemisphere or in the eastern hemisphere. I see the 0. That would be our prime meridian. It's to the right of the prime meridian, telling me it's to the east. So that's definitely in the eastern hemisphere. And it's definitely in the south. By the way, if that's your prime meridian, everything that way is going to be east. In fact, that east continues all the way to the 180. So all of these are east. Which is weird because it's on the left side of the map. You want to call this west, right? Well, we're looking west of the prime meridian. All of these are going to be your wests. Just like everything above the equator is going to be your north, and everything below is going to be your south. And if it helps you to do this right when you get your Regents, your reference table, fill it out that way. But back to Bouvet. Bouvet, we said, was on the eastern hemisphere, and it was in the southern hemisphere, east and south. Our answer would be 2. I'm just going to pause this. Now it's recording. Okay, next up. As the distance from the mid-Atlantic ridge increases, the age of the ocean floor bedrock does what? So let's draw a crude drawing of what it looks like. So if this is the mid-Atlantic ridge, we call it a ridge because it's a ridge, it's a bump in the middle of the Atlantic Ocean. And we know that the youngest bedrock is here. Why is it young? Well, because this is a volcano, or I should say a ridge of volcanoes. As we move further out, it's going to get older on both sides. So as the distance from the Mid-Atlantic Ridge increases, the age of the ocean floor increases. Next up, 27. Graph below shows the decay of a 50-gram sample of a radioactive isotope over 30 days. Now, they don't tell you what isotope this is, so looking on reference table page 1 isn't going to be a lot of help. Now, page 1, when you have specific ones, does help. But for right now, let's try and figure this out. It says we started off with 50. A half-life is when half of it decays. So what's half of 50?
25.
Yeah, we're at 25, which is right there. And then if we carry that straight down, it looks like about 7.5. Our answer is 1. 28, based on fossil evidence, which pie graph best shows the percentage of time humans have existed on Earth since the Earth's origin? So most of time was without human. The answer is 1. How do we know that? Reference table page 8 and 9. And if we take a look at page 8, you can see right here, all the way at the top, basically at 0 million years ago, all right, maybe a little before that, is humans. Everything prior is not. Next up, we're looking at drainage patterns. The photograph shows a cone-shaped volcano. Which stream drainage pattern would be found on this volcano? The answer would be 2. We refer to this as a radial drainage pattern. Radial means to go all the way around. So water runs here, 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 down that way, down that way. Now, as far as radials are concerned, that's when we have a sharp peak. But what about this one? This is referred to as annular. Annular means to go around the outside. Well, we had a hill, and that hill got eroded away. And when it got eroded away, all those harder layers underneath stayed behind. And the water has to travel through and around them. And that's why it looks like that. This one, I'm not sure what they're trying to show you. Maybe a meandering river, not sure. This one right here is called terraced. And terraced is when you have a series of hills and the water rolls between each hill. Yeah, I mean, if it looks like a cone-shaped volcano, yeah, you'll find that. Mount McKinley is a good example of it. Any mountain that's pointy. 30. Topographic map below shows the features of a coastal location. Well, how would you do this? You'd actually go through each and mark the values for them. Now, I'm not going to do that. I will, however, say that that's like high, and this would be our low area, and this is higher. So if I line this up, I can see that the lowest area would probably be lined up with it here. So I think, could it be this one? Does it drop down a lot? This one shows 100. Do we go back over 100? We do. This one, if that would be 100, that would be 120, 40, 160, 160. So it looks like probably the best one would be 2. (31) Block diagram below represents a meandering river. Greatest amount of erosion happens where? Remember, when you fall off your bike, you're going to get the most erosion on the outside of your elbow. Same thing with the river. A and D. The answer is 4. Now take a look at this cross section. Where would the water be moving the fastest? Right here. Not touching the outside. Probably shouldn't even be touching the bottom. Friction slows it down. So it would be towards the outside of the elbow where the water moves fastest. Next up, map of locations shows drumlins. What makes drumlins? Glaciers. So a drumlin is a pile of glacial till. The word till, just like a farmer might till the field, is mixed up rocks. So we got rocks and dirt. Now, you're always going to have a blunt side, and you're going to have a tapered side. The blunt side shows where the glacier hit it, and the taper shows where the glacier slid over it. So, which way did the glacier go? We're looking at our compass rose. This glacier went to the east. What about these guys? You can see that we have the blunt part up top, tapered on the bottom left. Blunt up top, tapered on the bottom left. So that tells us that the glacier came down from up here, and it moved to the southwest. And those are drumlins. Say again? Glaciers drop off piles of dirt and rocks, and then the dirt and rocks get run over by the glacier. Big flat side, and then they get dragged out. 33. The landscape diagram below represents a fan-shaped feature that is composed of sediments that were transported and deposited by a stream entering a lake. If you ever have sediments that are in the form of this triangle shape or fan shape, this is known as a delta. Delta, you might have learned that is the one of the Greek letters, which basically means the letter D, and in this case it's a triangle, and that's one way you can remember delta. What are watersheds? Watersheds are areas that dump out their water into a certain spot. So this is not a watershed. This is part of a watershed. Right? This is where it gets dumped out, but not the area that filled that up. We also have moraines. Moraines we can find at the ends of glaciers. So if here's our glacier, we could have a terminal moraine, which is a pile of rocks at the end of the glacier. We could have lateral moraines, which are on the sides, just like your lats are on the sides of your body. We could also have central moraines, which are right in the middle. And all that a moraine is just rocks that are caught up in a glacier. The tendency of a mineral to be split along flat surfaces indicates the mineral's property called cleavage. So cleavage is when they break into flat sheets. Can we name a few minerals with cleavage? Well, you could always take a look at the back of your reference table, ESRT back page, and you can see here we've got cleavage and fracture. Cleavage is the one on the left, and you can see that graphite has cleavage, galena has cleavage, talc has cleavage. All of those have cleavage. I guess one of the biggest ones that you probably would remember would be halite, aka rock salt. That was the one that was perfectly cube-shaped. 35. The data table below shows a student's observation of a mineral sample. Based on a student's observation, the mineral can be best described as what? Brassy yellow in color and metallic. ESRT, back page. Metallic, we're in the metallic section. Let's find brassy yellow, there it is. The answer is pyrite. That was easy, it's a gimme. Next up, we're into astronomy. I see the Earth and all the phases of the moon. Now remember, this is a top-down view. This is not actually what the moon looks like to the person on Earth. Here it says, which diagram represents the gibbous phase of the moon as seen by an observer in New York State? Excuse me, the new gibbous phase. So, first step, you're going to rotate your paper so the phase you're looking at is above you. So I got my little guy. He looks up. Remember, he can't see behind the orbit, behind the orbital line. But what he can see is on the left, a sliver of dark, and on the right, a bunch of light. Left, sliver of dark, right, bunch of light. The answer is 3. Question. The other way is, just remember, if you could fit a capital letter G in there, it's a gibbous. If you could fit a letter C or a backwards letter C, it's a crescent. That's another way you could do it real quick. But whether it's a new gibbous, aka a waxing gibbous, or a waning gibbous, aka a last gibbous or an old gibbous, there you go. How many days are required for the moon to do a complete cycle of phases from full moon phase to the next full moon? Not 15, not 365. We know those are no-goes right off the bat because they don't make sense. Take a guess. We're looking at 28 most of the time. 27 is pretty close, but so is 29. 27.3 you need to remember as two things. It's the revolution and the rotation rate. But 29.5, that's how long a full set of phases. Now, why does that take longer than the moon going around the Earth? Well, actually, it's pretty simple. It takes 1/12 of a year for the moon to do one orbit of the Earth, right? And in that time, the Earth is still going around the sun. So the moon's got to catch up. So it takes it another couple of days for it to get to that position. Don't worry about the logic behind it. Just remember the full set of phases is 29.5, where revolution and rotation is 27.3. 29.5. At which two moon phases will the difference between high tide and low tide most likely be the greatest? The answer would be new moon and full moon. Why? At new moon and full moon, we have something called a spring tide. So if you remember, we've got the sun, we've got the earth, and we've got the moon. This is a spring tide. We could also have it where it's the sun, the moon, and the earth, and get rid of that one. That's also a spring tide. What's the deal with the spring tide? When does it happen? It happens all year long. It doesn't just happen in the spring. The word spring in this case means that the ocean water seems to spring up because we have really high tides and low tides. We also have neap tides. And a neap tide is where we have the sun, the moon, and the earth at perpendicular to each other. They're not parallel. They're not going in the same direction. So we could also have it where the moon is here or the earth would be here, right? So it could be on both sides. 39. Eclipses do not occur each time that a moon goes around the earth because the moon's what? There's the earth. There's the moon. Since the moon is going around the earth at an angle, here's the sun, a lot of the time the sunlight just makes it to the earth and it's not blocked at all. It's all because the earth, the moon, its orbit is tilted. The word inclined in this case means tilted. 40. The same side of the moon always faces Earth because the period of revolution of the moon is what? Remember, the revolution always equals the rotation of the moon. ESRT, page 15. If you go to page 15, you can find it right there. Earth's moon, 27.3, 27.3. Since it's matched, that means the moon is tidally locked to the Earth and will never show a different face. Question 41. The outwash sediment that formed Scobie Hill is best described as what? These layers are sorted because they've got clay on the bottom and silt on top. They are also layered because I see separate layers. The answer is 1. The maximum diameter of the particles in the fill was what? So they ended up filling up some of the land on here to build a road. The fill was made up of different sized particles, including clay, silt, sand, and pebbles. They're saying, what was the biggest piece of fill? ESRT, page 6. The largest thing they mentioned was pebbles, and the largest pebble was 6.4 centimeters. 43. The drain pipes that were installed lowered the water table by doing what? If you install drain pipes, you can do what? You can remove infiltrated water from the ground. It's infiltrated, yeah, right? Infiltrated is when water goes into the ground, and to pump it out would make the soil more stable. 44. In which New York landscape region is Scobie Hill located? Scobie Hill, it says, is 40 miles south of Buffalo. Earth Science Reference Table, page 3. Buffalo is located here. And if you go 30 miles south, well, there's our scale. So 30 miles south would be right about here. Now, I don't see a landscape region written here. But if I flip the page, there it is. It's part of the Allegheny Plateau. By the way, I did these questions without reading through the passage, just to save some time because we're running short today. Don't skip it in real life. Read the passage. Read it again if you have to. 45. The number 2.5 on this station model indicates what? ESRT, page 13. On page 13, you can see that we have our station model. We have the weather like we always spoke about.
Pardon the interruption. There will be cheerleading trials today through Thursday at 3:30 starting in the back gym. Hope to see you there.
And if you take a look, guys, hold on. You can see they show you in this example 1/2 mile for visibility. Well, what does this mean? 2.5 miles for visibility. The answer is 2. Question 46. Which present weather symbol represents the form of precipitation that is most likely occurring? Well, the temperature is 86 Fahrenheit. 84 is the dew point. That means it's probably going to have some kind of precipitation because when the dew point hits the temperature, we get rain. But what kind of precipitation could we have? Could we have snow cone? The snow cone looking like guy is rain showers. Yeah, and that would make sense. We could definitely find rain showers. This one that kind of looks like the Illuminati symbol, triangle with the dot in it. That is sleet. No, we're not going to get sleet in 86 degree weather. This one, snow showers. No, again, we're not getting that in the snow. This one, freezing rain. No. So our answer has to be number 1. 47. What are the wind direction and wind speed at this location? I have my wind barb, and off the wind barb comes 2 full feathers and a half feather. Full feathers are 10, half feathers are 5. 10 plus 10 is 20, plus 5 is 25. Our answer would be wind from the southeast, because it points in the direction it's coming from, at 25. Next up, 48. Rock Unit A was most likely formed by what? Rock Unit A is those lines. If we go to reference table, page 7, we could figure out what kind of lines those are. It looks like shale. There it is. That matches that. So shale, how do you make shale? Well, shale is a sedimentary rock. And if we go to our reference table here, shale would be made through compaction and cementation. Compaction of sediments. Our answer is 4. Question 49. Which 2 minerals would most likely be found in the igneous rock if the rock is highly mafic? The word mafic can be found on reference table page 6. Mafic means high in iron and magnesium. And some of the minerals that would be olivine and pyroxene. So you're going to go through all these, and then you're going to find olivine and pyroxene. Those 2 are mafic, therefore it's mafic. 50. Which metamorphic rock most likely formed at the interface between rock unit B and the igneous rock? So rock unit B is this, which, if we look on page 7 once again, tells us that is sandstone. And here we have our lava flow come up, and all those little tick marks means that the lava burnt the sandstone. So since the sandstone is burnt, it changed into a metamorphic rock. So what rock here, which one of these metamorphic ones, is formed from burnt sedimentary rocks? Sandstone. No, 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 no. Yes. Metamorphism of quartz sandstone, making it quartzite. Our answer is 1. And that is the multiple choice portion. All right, so these are the easy ones. This is where it gets challenging. Flip the page. Did I come around with your booklets? No. Give me one moment. I'll come around with that. Question 51. Salt, a valuable commodity. In New York State, salt is a valuable natural resource. Approximately 8,500 square miles of New York State has bedrock that contains rock salt. The layers of rock salt formed after parts of New York State were covered by a shallow inland sea, which eventually evaporated. That's where it came from. Groundwater dissolved some of the deeper rock salt layers and carried the salt water up to the surface in central New York. Commercial salt production began in the Syracuse area in the late 1700s. Early production of salt involved heating of the salty water by burning wood from the surrounding area. The heat vaporized the water, leaving the salt behind. When the lumber supplies dwindled, solar methods were used to evaporate the water. Although the salt industry had an overall positive effect on Syracuse, the industry in Syracuse closed down in the 1920s, leaving negative environmental effects. There are currently salt mines operating south of Syracuse in the Finger Lake region of New York State. Identify one process that formed rock salt from the shallow inland sea that covered parts of New York State. It says the layers of rock salt formed after parts of New York State were covered in a shallow sea, which eventually evaporated. The answer to 51 is salty water evaporated. And then you could even go on and say to make rock salt. I don't think you need that. In fact, I think even if you just wrote the word it evaporated, I think you'd be fine. 52. Identify the geologic time period during which the rock salt in the surface bedrock at Syracuse was formed. So what time period did that happen? Well, Earth Science Reference Table, pages 8 and 9. If we come back to here where it says geologic events in New York, you go down, it says salt deposited in evaporate basins. That salt that was deposited, that's the salt they're talking about. So let's move over to the previous page. That was during the Silurian time period. Now, if you didn't know to go there, this would be pretty difficult for you. In fact, I think there was another method. I think you could, because they said it was in the Finger Lake region, right? You could find these polka dots, Devonian, Syracuse here, vertical lines, Silurian. All right, question 53. Identify the name of one mineral that makes up rock salt and describe one use of this mineral. So let's find rock salt on Earth Science Reference Table, page 7. There's rock salt. Rock salt comes from halite. And what do we use halite for? ESRT back page. There's halite. Halite can be used for food additives and melting ice. '54. Describe one negative environmental effect that, yes, in melting ice. Describe one negative environmental effect that resulted from the mining of salt in Syracuse. What did they do in Syracuse to get the salt to evaporate? Something bad for the environment. Yeah, there was pollution being made. How? If you go back to the passage, it says here, by burning wood from the surrounding area. So, you could say deforestation. cutting down trees. 55. Identify the date of the sunrise position when the insolation from the noontime sun will become most intense. So, when is the sun the brightest out of all these dates? March 21st is one of the equinoxes, so it's actually right in the middle. 12/21 is the shortest day of the year, the first day of winter, so that would be the dimmest. So yeah, 6/21 would be the best. So for the date 6/21, this is the first day of summer, aka yes, summer solstice. You really should memorize that date. 56. A stick placed vertically in the ground at the observer's location and its shadow is observed from sunrise on January 21st. Identify the time of day when the shortest shadow is cast by the stick. So here is our celestial sphere, and I'm going to put a stick right in the middle. Let's say that that's north, that's south, that's west, that's east. When the sun rises on the equinox, it would rise right on the east. But this question's saying when? It was on January 21st, so it's basically the winter. So that means the sun is rising to the south of east. So this would be 3/21 and 9/21. Same thing for that. So what would be the path of the sun? It would look something like that on the equinoxes. Did it the wrong way. It would look something like that. Ignore this one. And in the winter, it would look like that. So you can see that the sun doesn't go up very high. But when would it make the shadow on the stick be the longest? Well, right at noon would be the shortest. At this point, with sunrise, it would give you a longer one. And at sunset, it would give you a longer one. So the shortest would be at noon. And if you think about it, at noon, that's when your shadow is the shortest. So the answer would be noon. Hope I didn't confuse anybody with that. Sunrise and sunset always create the longest shadow because think about it, if you see the sun coming up on the horizon, it's sideways, and your shadow is now infinitely long. It just keeps going. Let's see how many more we can get through. Question 57. State the general relationship between a planet's distance from the sun and the planet's period of revolution. ESRT, page 15. Distance from the sun is here. Revolution is here. As we get farther away, what happens to the revolution? Gets longer, right? So 88 days, 200 days, 300 days, 600 days, 12 years, 30 years, 84 years, right? So you can see how it increases as we move further out. So how would we answer that? The farther out, the longer the revolution. The farther away from the sun, the longer the revolution period. 58. Can we name the terrestrial planets? Well, there they are. Mercury, Venus, Earth, Mars. Those are the rocky little guys. And then we've got the Jovian planets, also known as the gas giants. That would be, bless you, Jupiter, Saturn, Uranus, and Neptune. '59. Explain why this diagram represents a heliocentric model of the solar system. Helio, as in helium, the element that was discovered on the sun, means it's sun-centered. So, heliocentric equals sun-centered. And conversely, sometimes in some old ones we might see it as the Earth in the middle. That would be known as a geocentric. Geo meaning Earth, also not true. 59. Explain why this one, we did that. 60. State one possible distance from the sun in millions of kilometers in which an asteroid in the asteroid belt can be found. Asteroid belt is found between the inner planets and the outer planets. So, if these are our terrestrials and these are our Jovian, it's somewhere between 227 and 778. I don't know, I'm going to say 300 million miles. Or kilometers, 300 million kilometers. And last one, calculate how many times greater Mercury's density is than Neptune's density. So Neptune's density is 1.8. Mercury's density is 5.4. If you get a calculator and you do 5.4 divided by 1.8, that's going to give you 3. So it is 3 times greater. All right, we are going to continue work on this tomorrow. We've got questions 62 through 85 to wrap up. We'll get those done. Piece of cake.